Hello everyone, welcome back to the next video. In this video we will be looking into the blog of React Native version 76. So they have created few blogs. So first one is the new architecture is here and second one is React Native 76. So we will be looking both. So first let's read about the new architecture is here. So let's see what this is. React Native 76 with the new architecture by default is now available on npm. In 0.7 release we have shared a significant list of significant changes included in this version. In this post we provided a overview of the new architecture, how it shapes the future of React Native. The new architecture adds support for modern React features like suspense, transitions, automatic batching, use layout effect. The new architecture also includes new native module and native component system that helps you write type safe code with direct access to native interface without a bridge. So like if you go through the documentation, they have updated the documentation. If you go into the native component docs, here you can see they have shown us how to create Android and iOS turbo modules. So basically like a business logic module. If you want to create view related modules, you can go to the native components module as well. And I think they are only now supporting the new architecture. If you want to make native modules with backwards compatible for the old architecture as well, you might have to go over here, backward compatibility guide. But the documentation has been completely updated to use the new architecture only. And there is also this cross platform with C++ and this custom C++ types as well. Let's see this later. Then here this release is the result of ground up rewrite of React Native we have been working on since 2018, and we have taken extra care of the new architecture gradual migration for most apps. In 2021 we created the new architecture working group to collaborate with the community on ensuring a smooth upgrade experience for the entire React system. Most apps will be able to adopt React Native 76 with the same level of effort as any other release. The most popular React Native libraries already support the new architecture. The new architecture also includes an automatic interoperability layer to enable backward compatibility with libraries targeting the old architecture. Over the past several years of development, our team has publicly shared our vision for the new architecture. If you missed any of this, you can check them out here. So these are all the talks. What is the new architecture? It is a complete rewrite of the major system that underpins React Native, including how components are rendered, how JavaScript abstraction communicates with native abstractions, and how work is scheduled across different threads. Although most users should not have to think about how the system works, these changes bring improvements and new capabilities. In the old architecture, React Native communicated with the native platform using an asynchronous bridge. To render a component or call a native function, React Native need to serialize and enqueue native function calls with the bridge, which would be processed asynchronously. The benefit of this architecture is that the main thread was never blocked for rendering updates or handling native module functions, since all the work was done on a background thread. However, user expects immediate feedback to interactions to feel like a native app. This means some updates needs to render synchronously in response to user input, potentially interrupting any in progress render. Since the old architecture was only asynchronous, we needed to rewrite it to allow both asynchronous and synchronous updates. Additionally, in the old architecture, serializing function calls over the bridge quickly become a bottleneck, especially for the frequent updates or large objects. This made it hard for apps to achieve 60 fps reliably. There were also synchronization issues. When this JavaScript and native layer got out of sync, it was impossible to reconcile them synchronously, resulting bugs like list showing frames of empty space and visual UI jumps due to intermediate states rendering. Finally, since the old architecture kept a single copy of the UI using the native hierarchy and mutated that copy in place, layouts could only be computed on a single thread. This made it impossible to process urgent updates like user inputs, and layout could be read synchronously, such as reading in a layout effect to update the position of a tooltip. All of this problem meant that it was impossible to properly support React's concurrent feature. To solve this problem, the new architecture includes four main parts: the new native module system, the new renderer, event loop, and removing the bridge. The new module system allows React Native renderer to have synchronous access to the native layer, which allows it to handle events, schedule updates, and read layout both synchronously and asynchronously. The new native modules are also lazily loaded by default, giving apps a significant performance gain. The new renderer can handle multiple in-progress trees across multiple threads, which allows React to process multiple concurrent update priorities either on the main thread or on a background thread. It also supports reading layout from multiple threads synchronously or asynchronously to support more responsive UIs without jank. The new event loop can process tasks on the JavaScript thread in a well-defined order. This allows React to interrupt rendering to progress events, so urgent user events can take priority over lower priority UI transaction. The event loop also aligns with web specifications, so we can support for browser features like microtask, mutation observer, and interaction observer. Finally, removing the bridge allows for faster startup and direct communication between JavaScript and the native runtime, so that the cost of switching work is minimized. This also allows for better error reporting, debugging, and reducing crashes from undefined behavior. The new architecture is now production ready to be used in production ready. It is already used at scale at Meta in Facebook app and in other products. We successfully used React Native and the new architecture in the Facebook and Instagram apps we developed for our Quest devices. Our partner have successfully been using new architecture in production for months now. Have a look at this success story by Expensify, Kraken, and give Blue Sky a shot with their new release. Also, let's see, just come here, let's see suspense, transitions, automatic batching, and use layout effect. Do they have documentation for this, or is it just they are just pointing it to the React Native docs? So this, I think, feels, I'm not really sure how will it be any good or not, because they are just pointing to the React Native docs for this, which is a little disappointing. I mean, more or less they would be the same how we use in React Native, but sometimes I did notice that previously when I was using suspense, it was very difficult with React Native at least. The new native module system is a major rewrite of how JavaScript and native platform communicate. It's written entirely in C++, which unlocks many new capabilities: synchronous access to and from native runtime, type safety between JavaScript and native code, code sharing across platform, lazy module loading by default. In the new module system, JavaScript and the native layer can now synchronously communicate with each other through the JavaScript interface without the need to use an asynchronous bridge. This means your custom native modules can now synchronously call a function, return a value, and pass that value back to another native module function. In the old architecture, in order to handle a response from native function calls, you needed to provide a callback and the value returned needed to be serializable. So something like this. In the new architecture, you can make synchronous calls to native function, so something like this. With the new architecture, you can finally leverage the full power of C++ native implementation while still accessing it from JavaScript TypeScript API. The new module system support modules written in C++, so that you can write your module once and it works across all platforms, including Android, iOS, Windows, and macOS. Implementing modules in C++ allow for more fine-grained memory management and performance optimization. Additionally, with CodeGen, your module can define a strong type contract between JavaScript layer and the native layer. From our experience, cross-boundary type errors are one of the most common sources of crashes in cross-platform app. CodeGen lets you overcome those problems while also generating boilerplate code for you. Finally, modules are now lazy loaded. They are loaded in memory only when they are effectively needed rather than at startup. This reduces the app startup time and keeps it low as the application grows in complexity. Popular libraries like React Native MMKV has already seen benefits from migrating to the new architecture. So he says that the new native module generally greatly simplified setup, auto linking, and initialization for React Native MMKV. Thanks to the new architecture, is now a pure C++ module which allows it to work on any platform. The new CodeGen allows MMKV to be fully type safe, which fixed a long-standing null pointer reference issue by enforcing null safety, and being able to call native module functions synchronously allowed us to replace custom JSI access with the new native module API. New renderer, we have also completely rewritten the native renderer, adding several benefits. Updates can be rendered on a different thread at different priorities. Layout can be read synchronously across different threads. The renderer is written in C++ and shared across all platforms. The updated native renderer now stores the view hierarchy in an immutable tree structure. This means that the UI is stored in a way that cannot be changed directly, allowing for thread-safe processing of updates. This allows it to handle multiple in progress tree, each representing a different version of the user interface. As a result, updates can be rendered in the background without blocking the UI, such as during transition or on the main thread in response to the user input. By supporting multiple threads, React can interrupt a low priority update to render an urgent one, such as those generated by user input, and then resume the low priority update as needed. The new renderer can also read layout information synchronously and across different threads. This enables background computation for lower priority updates and synchronous reads when needed, such as repositioning a tooltip. Finally, rewriting the renderer in C++ allows it to be shared across platforms. This ensures that the same code runs on iOS, Android, Windows, macOS, and any other React Native supported platform, providing consistent rendering capabilities without needing re-implementation for each platform. This is a significant step towards many platform vision. For example, view flattening was an Android only optimization to avoid deep layout trees. The new renderer with the shared C++ core brings this feature to iOS. This optimization is automatic and does not require setup. It comes for free with the shared renderer. With these changes, React Native now fully supports concurrent React features like suspense and transitions, making it easy to build complex user interface that responds quickly to user input without jank, delays, or visual jumps. In the future, we will leverage these new capabilities to bring more improvements to built-in components such as flat list and text input. Popular libraries like Reanimated are already taking advantage of the new renderer, and this is their feedback. The event loop, the new architecture allow us to implement a well-defined event loop processing model as described in this RFC. This RFC follows the specification described in the HTML standard, and it describes how React Native should perform a task on the JavaScript thread. Implementing a well-defined event loop closes the gap between React DOM and React Native. The behavior of a React Native application is now closer to the behavior of a React DOM application, making it easier to learn once and write anywhere. The event loop brings many benefits to React Native: the ability to interrupt rendering, to process events and tasks, closer alignment with web specification, foundation for more browser feature. With the event loop, React is able to predictably order updates and events. This allows React to interrupt a low priority update with an urgent user event, and the new renderer allows us to render those updates independently. The event loop also aligns the behavior of events and tasks like timers with web specification, which means React Native works more like what users are familiar with in the web and allows for better code sharing between React DOM and React Native. It does allow for the implementation for more compliant browser features like microtask, mutation observer, and intersection observer. These features are not ready to use in React Native yet, but we are working on bringing them to you in the future. Finally, the event loop and the new renderer changes to support reading layout synchronously, allowing React Native to add proper support for use layout effect to read layout information synchronously and update the UI in the same frame. This allows you to position elements correctly before they are displayed to the user. See use layout for more details. Removing the bridge. In the new architecture, we have fully removed React Native's dependency on the bridge, replacing it with a direct, efficient communication between JavaScript and native code using JSI. So here you can see the diagram. Removing the bridge helps improve startup time by avoiding bridge initialization. For example, in the old architecture, in order to prevent global methods to JavaScript, we would need to initialize a module in JavaScript on startup, causing a small delay in app startup time. So something like this. And new architecture, we can directly bind methods from C++. The rewrite also improves error reporting, particularly for JavaScript crashes at startup, and reduces crashes from undefined behavior. If crashes occur, the new React Native dev tools simplify debugging and support the new architecture. The bridge remains for backward compatible to support gradual migration to the new architecture. In the future, we will remove the bridge code completely. We expect most apps can upgrade to 76 with same effort as any other release. When you upgrade to 76, the new architecture and React 18 are enabled by default. However, to use the concurrent feature and gain the full benefits, your app and libraries will need to gradually migrate to fully support new architecture. When you first upgrade, your app will run on the same will run on the new architecture with an automatic interop layer with old architecture. For most apps this will work without any issue, but there are known limitations with the interop layer, as it does not support accessing custom shadow nodes or concurrent feature. To use concurrent feature, app will also need to be updated to support concurrent React by following the rules of React. To migrate your JavaScript code to React 18 and its semantics, follow the React 18 upgrade guide. The overall strategy is to get your application running on the new architecture without breaking existing code. You can then gradually migrate your app at your own pace. For new surfaces that have migrated all modules to the new architecture, you can start using concurrent features immediately. For existing surfaces, you may need to address some issues and migrate modules before adding concurrent features. We have collaborated with most popular React Native libraries to ensure support for the new architecture. More than 850 libraries are already compatible, including all libraries with over 200k weekly downloads. You can check library compatible with the new architecture on the reactnative.directory website. Okay, new feature. The new architecture includes support for React 18 concurrent feature. Use layout effect in React Native. For a full list of React 18 features, see the React 18 blog post. Okay, transitions are new concept in React 18 to distinguish between urgent and non-urgent update. Urgent update reflect direct interaction like typing and pressing. Transition updates like transition the UI from one view to another. Urgent updates need immediate response to make our intuitions about how physical objects behave. However, transitions are different because the user doesn't expect to see every intermediate value on screen. In the new architecture, React Native is able to support rendering urgent updates and transition updates separately. Typically, for the best user experience, a single user input should result in both an urgent update and a non-urgent one. Similar to React DOM, events like press or change are handled as urgent and rendered immediately. You can use the start transition API inside an input event to inform React which updates are transition and can be deferred to the background. So yeah, something like this looks nice. Maybe I should be using something like this more often. Start transition, mark any states inside a transition. Separating urgent event from transition allows for a more responsive user interface and a more intuitive user experience. Here is a comparison of the old architecture without transition left and the new architecture with the transition right. Automatic batching. When upgrading to new architecture, you will benefit from automatic batching. Automatic batching allows React to batch together more state updates when rendering to avoid the rendering of intermediate states. This allows React Native to be faster and less susceptible to lags without any additional code from the developer. In the old architecture left, more intermediate states are rendered and the UI keeps updating even when the slider stops moving. The new architecture right renders fewer intermediate states and completes the rendering much sooner thanks to automatic batching the updates. Use layout effect. Building on the event loop and the ability to read layout synchronously, in the new architecture we added proper support for use layout effect in React Native. In the old architecture, you needed to use a synchronous on layout effect event to read layout information of a view, which was also synchronous. As a result, there would be at least one frame where the layout was incorrect until the layout was read and updated, causing issues like tooltips placed in the wrong positions. So yeah, something like this view with tooltip. The new architecture fixes this by allowing synchronous access to layout information in use layout effect. This change allows you to read layout information synchronously and updates the UI in the same frame, allowing you to position elements correctly before they are displayed to the user. Full support for suspense lets you directly declaratively specify the loading state for part of the component tree if it's not yet ready to be deployed. We introduced a limited version of suspense several years ago and React 18 added full support. Until now, React Native was not able to support concurrent rendering for suspense. The new architecture includes full support for suspense introduced in React 18. This means that you can now use suspense in React Native to handle loading states for your components, and the suspended content will render in the background while the loading state is displayed, giving higher priority to user inputs on visible content. How to upgrade to 76? Follow the steps in the release post. We'll go through the release post in a bit. Since this release also upgrades to React 18, you will also need to follow the React 18 upgrade guide. These steps should be enough for most apps to upgrade to new architecture thanks to the interop layer with the old architecture. However, to take full advantage of the new architecture and to be start using concurrent features, you will need to migrate your custom native components and native modules to support the new native module and native components API. Without migrating your custom native components, you will not get the benefits of the shared C++ synchronous method calls or type safety from CodeGen. Without migrating your native components, you will not be able to use concurrent features. We recommend migrating all native components and native modules to the new architecture as soon as possible. Apps. If you are an app developer, to fully support the new architecture, you will need to upgrade your libraries, custom native component and custom native modules to fully support the new architecture. We have collaborated with the most popular React Native libraries to ensure support for the new architecture. You can check library compatibility with the new architecture on the React Native.directory website. If any of the libraries your app depends on are not compatible yet, you can open an issue with the library and ask the author to migrate to new architecture. If the library is not maintained, consider alternative libraries with same feature. Opt out from the new architecture while those libraries are migrated. If your app has a custom native module or custom native component, we expect them to work fine thanks to our interop layer. However, we recommend upgrading them to the native module and native component API to fully support the new architecture and adopt concurrent features. Please follow these guides to migrate your component and modules to the new architecture. So yeah, we'll go through this as well. Libraries. If you are a library maintainer, yeah, this is fine. Opt out. If for any reason the new architecture is not behaving properly in your application, there is always the option to opt out from it. To opt out, you can disable this as false. On iOS, you can reinstall the dependency by running this command. Thanks. Okay, so delivering the new architecture, yeah, has been a great effort. We are extremely Expo, Software Mention, CallStack, Microsoft, Expensify, Kraken, Bluesky, Brigade, all the independent. Yeah, so I think that's it. Next is the React Native 76 release. So this is a major milestone for React Native as we are enabling the new architecture by default and we are introducing React Native DevTools. This has been the culmination of 6 years of hard work from our team together with the support of our incredible community members. Let's see when 75 came out. 75 came out in August 14th. So in I think 2 months and 10 days they were able to release the next version, which is good. React Native new architecture by default, React Native DevTools, faster metro resolution, box shadow and filter style props. I'm really looking for this box shadow and filter style. Remove the dependency on React Native community CLI. Android apps are 3.8 MB smaller and updates to minimum iOS and Android SDK requirements. React Native new architecture by default. Starting from React Native 76, the new architecture is enabled by default in your projects. The new architecture is rewrite of the internals of React Native to enable app developers to develop high quality applications using React. Today we are excited to declare new architecture ready for production use. This change is a milestone in the evolution of React Native, and we invite you to read the dedicated blog post to understand what's included in the new architecture and how it will shape the future of React Native. The new architecture is here. We are releasing the first stable version of React Native DevTools, our new default debugging experience. We want the tooling you use to debug React across all platforms to be reliable, familiar, simple and cohesive. React Native DevTools deliver on these principles. Browser aligned developer tools that are deeply integrated with React Native. Key features include familiar web aligned tooling, a fully featured debugger based on Chrome DevTools, which is reliable, breakpoints, watches values, step through debugging, stack inspections, and a rich JavaScript console. These core features will now work reliably across reloads Improved and integrated React Dev Tools. The built-in React component inspector and profiler work seamlessly with faster and more reliable component, highlighting improved UX. See a new paused in debugger overlay, making it clear when your app is paused on a breakpoint. Warning in logbox are now displayed as summary and hidden when dev tools are attached. Fixed reconnection behavior. JavaScript breakpoints can now work reliably across reloads when dev tools is disconnected and reattached. Dev tools can reconnect to the same app after a native rebuild. Fixed reconnection behavior. JavaScript breakpoints now work reliably across reloads when dev tools is disconnected and reattached. Dev tools can now reconnect to the same app after a native rebuild. Instant launch. React Native dev tools is ready by default with zero config. Open it from in-app dev menu or via J to debug in the CLI server, which now supports multiple emulators and devices. React Native DevTools is fundamentally different from our previous debugging option, including being different from the experimental debugger experience first shipped in 73. It switches to a new backend debugging stack that we have rebuilt over the last year. This means that compatibility with the previous tooling has changed, and you should also expect a much more reliable experience end to end. We intend to build upon this stack to allow us to reliably implement more features in the future, such as performance and network panel. Phasing out logs in Metro. In our next release, we are removing forwarded logs in Metro to align with modern browsing tools and removing old debugging integrations. Instead, use React Native DevTools fully featured console panel for logging. A faster Metro resolution. We have shipped several performance improvements to our Metro's resolver. The component responsible for finding a module from an import path, making it around 15 times faster. This improves the overall performance of Metro, particularly for warm build, which we have seen at around 4x times faster. Box shadow and filter style props. We have added two new architecture only style props in 0.76, box shadow and filter. Both of these props exist on the web, and the team stick to the specs when possible so that these props are predictable, familiar, and ultimately easier to adapt. See the limitations and spec deviation sections for the exceptions. As a result, you can now look up the web documentation to fully understand how this works, but there are few important differences which are noted below. Box shadow adds a shadow to an element with the ability to control the position, color, size, and blurriness of the shadow. Check out the MDN documentation for a full overview for each of these arguments along with the fiddle to try them out yourself. Below are few examples of shadows you can make. Box shadows can take either a string which mimics the CSS syntax or JS objects which can embed variables. For example, the string and the object would yield the same shadow box. The previous shadow functionality had some shortenings now addressed by box shadow. Does not work on Android, cannot be inset, does not have spread, does not works on view if there is no background color, is a separate prop so it cannot share the same web syntax. Limitation and spec deviation. The default shadow color is black, not the parent's color. Android normal shadow are supported on Android 9 plus. Android inset shadow are supported on Android 10 plus. Filter adds certain graphical filters to an element. There are mix of color filters that let you modify things like brightness, saturation, hue, as well as non-color filters that let you add blur and shadows. Check out the MDN documentation for a full overview of each individual filter function along with the fiddle to try them out for yourself. Below is a hot dog image with various filters applied to it. Like box shadow, filter can take either a string which mimics the CSS syntax or an array of JS objects which can embed variables. For example, the string saturate 0.5 grayscale 25 and the array would yield the same filter. Filter has a drop shadow value which varies slightly from box shadow. The big difference is that drop shadow is an alpha mask, so that the shadow will only be cast by a pixel if it has a non-zero alpha component. Box shadow on the other hand will cast around the border box of the element even if nothing is inside of it. Additionally, drop shadow does not have a spread distance parameter and cannot be inset shadow cast inside of the element. Limitation and spec deviations. IOS filter only supports brightness and opacity. IOS filter will not allow to apply shadows, outlines or any other graphical elements outside the bounds of the element. Android blur and drop shadow are only supported on Android 12 plus. Filter applies overflow hidden, so children of an element with a filter will be clipped if they are positioned outside of the parent bounds. Breaking changes. Remove the dependency on React Native Community CLI. As previously shared in 75, our vision for React Native to be a framework agnostic. Therefore, we completed the work to remove React Native CLI as a direct dependency of React Native. Decoupling React Native from the CLI allows us to move faster through releasing these projects independently and to be better separate the responsibility of both projects. If you are relying on the CLI in your daily workflow, make sure to add the dependencies on CLI in your package.json. Android apps are 3.8 MB smaller thanks to native library merging. React Native 76 will ship with a reduced number of native libraries as we merged a lot of our native code into a single library called libreactnative.so. This change comes with reduction in app size and improvements in app startup performance on Android. From our benchmark, we found out that app size will be reduced by 3.8 MB, 20% of the total, and the median app startup time will be reduced by 15 milliseconds. On the other hand, this is a breaking change for both app and library developers. App developers will have to update their applications on create as follows. This change is necessary in order to properly load libreactnative.so and is included in the upgrade helper. Library authors won't be affected by this change unless you have a custom C++ code. For a technical deep dive into this change and suggestion for library author, you can read more about it in the dedicated post. Upgrade to minimum iOS and Android SDK requirements. We have updated our minimum platform and SDK version. iOS from 13.4 to 15.1, Android 23 to 24. This change was announced earlier in the year when 75 was released. For more background, please see the dedicated blog post for Android and iOS. Other breaking changes. Animation. Stop sending state updates to React in looping animation. This was causing unnecessary re-rendering with looping animations. Remove inspector panel perf plus network tabs under the new architecture. Always use attributed string box instead of attributed string in text layout manager. Android rendering view backgrounds are no longer directly React view background drawable or CSS background drawable. iOS turbo module. Remove the RCT export CSX module experimental macro for auto linking pure C++ module. Acknowledgements. So these are the people who helped it. Upgrade. So instead of React Native CLI, you can use React Native Community CLI. So something like this to scaffold a project, or you can directly use Expo. So yeah, that's it. Like I said, they if you go to their documentation, so yeah, I'll just bookmark this documentation as well. So if you, let's see what exactly have they changed, because I have created a ton of tutorials using the new architecture and I have been creating it since March of 2023, or maybe even earlier, I think Feb or 2023, something like that. So it's been almost 1.5 years, more than 1.5 years since I have been creating new architecture tutorials. Let's see. Native modules. Your React Native application code may need to interact with native platform APIs that are provided by React Native or existing library. You can write the integration code yourself using a Turbo Native module. This guide will show you how to write one. Define a JavaScript specification using one of the popular JavaScript type annotation language, Flow or TypeScript. Configure your dependency management system to run CodeGen, which converts the specification into a native language interface. Write your application code using your specification and write your native platform code using the generated interface to write and hook your native code into the React Native runtime environment. Let's work through each one of this step by building an example Turbo Native component. The rest of this guide assumes that you have created your application running the command. So yeah, here we create we can use React Native CLI to create a sample one. Okay, then native, this guide will show you how to write an implementation of the web storage API local storage. This API is related to React developer who might be writing application code on your project. To make this work on mobile, we need to use Android and iOS API. Android shared preference is deprecated. You should use something called preferences data store, and iOS NS user defaults. Declare type specification. React Native provided a tool called CodeGen which takes specification written in TypeScript or Flow and generates platform specific code for Android and iOS. The specification declares the methods and data types that will pass back and forth between your native code and React Native JavaScript runtime. A Turbo Native module is both your specification, the native code you write in the CodeGen interfaces generated from your specification. To create a specs file, inside the root folder of your app, create a new folder called specs. Create a new file called native local storage.h. So the documentation has changed a lot. Here is an implementation of the local storage specification. So this is for TypeScript. So they are basically creating a project, and here they are creating a specs folder inside the root folder of your app, and then they are creating this file. Then inside that they have all this. Okay, this seems similar to what we have done. Then configure CodeGen to run. The specification is used by React Native CodeGen to generate. Okay, so I think this one is good. The previous one was little difficult to generate platform specific interfaces and boilerplate for us. To do this, CodeGen needs to know where to find our specification and what to do with it. Update your package.json to include this all stuff. So here we can see all the CodeGen stuff. With everything wired up for CodeGen, we need to prepare our native code to hook into our generated code. CodeGen is part of the script phases that automatically added to the project generated by CocoaPods, and this is for Android. Gradle Duck. So we'll have to run this particular code, and for iOS we'll have to run this particular code. The output will look like this. Writing application code using the Turbo, using native local storage. Here is a modified that includes some text we want to persist it, and input field and sub button to update this value. The Turbo module registry supports two modes of retrieving a Turbo native module, which will throw an exception if the Turbo native module is unavailable. This assumes that the module is always available. So here they are creating a state. Okay, another state. Here they are fetching our item from our Turbo module. Here they are saving, here clearing, here deleting. Okay, and these are some styles. Writing your native code. With everything prepared, we are going to write native platform code. We do this in two parts. This guide show how to create a Turbo that works with the new architecture. Yeah, for old architecture compatibility you'll have to go this. I don't really care about the old architecture. Let's see Android first. Now it's time to write some Android platform code to make sure local storage survives after application is closed. So basically the first step is to implement the generated native local storage spec interface. So Android app src main. So I think they will create this particular file, or will have to create this particular path or file. I'm not really sure. I'll have to try it out by myself. So I think this is also very similar, but previously we were creating all this inside our folder. Now I think they have shifted to the main Android folder, which I think is a good thing. Yeah, the Kotlin one is a better one, which I can understand. It is more or less the same. Yeah, here they are writing the implementation. I think only the structure has changed a little. Next we need to write a native local storage package. It provides an object to register our model in the React Native runtime by wrapping it up as a Turbo Native package. Yeah, this also seems fine to me. Finally, we need to tell React Native in our main application how to find this package. We call this registering the package in React Native. Wait, let me also check it for iOS. So this is for iOS. So open our XC workspace, create a new group, file from template, Cocoa Touch class, Objective C as the language, rename it to Objective C++. Okay, then add all this code, then update our implementation. Okay, build and run. Okay, I think they have simplified it a bit. We don't need the header file. Okay, and here we have to add this particular, but I'm still worried, like few of the APIs like using register for activity result, I'm still not sure how we can use this in this particular native storage module, or even if we try to use it within here inside our app, how will the native local storage package will know about it? Then we can just run it like this. Okay, then components, if you want to build new React Native, I'm not interested in this C++. I'm not really good at C++, so I'm not interested in that. So here they are just created one project. Okay, you are going to need a simple plain template generated application to use the component. So here creating a web view component. Let's start by creating folder structure. So here is our application. Inside that src, this is iOS, and we have to create this spec file. Okay, is the folder that will contain our Android code. So inside our spec file, if you are using TypeScript, and this is just to check whether the web view has been loaded or not. This is the source URL, and this is the OnScript loaded bundle bubbling event handler, which I think is good. Thank God they gave this as an example as well. Then what exactly are they doing? Configuring CodeGen to run. Okay, so this is the same thing. Build your native code. So let's see for Android first. So they are just running this particular command. Okay, write the React web view. So yeah, they are writing all the code for it. Here they are emitting one event, and here is the actual code, right? No, this is not the actual code. This is also not the actual code. Where is that web view? Okay, they are directly implementing from the Android web view, so they don't have to write some code for it. Yeah, and here they are just directly loading whatever URL you are passing. Okay, and here they are, once the page has been loaded, they are emitting this particular event, which is good. Okay, so this is so this is also again they emitting the event, and here I think they are just registering it. Here they are registering inside the main application, and this is how they are using it. Okay, so here we get a callback. Okay, and let's see for iOS how they are doing it, what all things have changed. So here is our iOS. So again they are just running our CodeGen, then opening Xcode, creating a new group, creating a new file, creating an Objective-C file, changing into Objective-C++. So there is this header file as well as this Objective-C++ file. This is our header file, this is our Objective-C++ file, and here they are using it, and this is how they send the content. Okay, and this I think is one more file. Yeah, inside app delegate, maybe we have to register this using your native components. Okay, so yeah, there are a couple of changes I'm planning to make tutorials for this. Also, like I have made a lot of tutorials on React Native new architecture. It would be impossible for me to remake all of them based on this code which we have. So if you want any particular tutorial, do let me know in the comments. I will try my best to make videos on those at least, because this is such a big breaking change. I'm not sure if the old way of creating the new architecture works on React Native 76 or not, but it's better not to try that approach, because I still have few videos lined up which uses the old way of creating the new architecture. So yeah, let's see if you have any suggestions on which tutorials I should make with this new architectures new template which they have introduced in 76. Do let me know in the comments. Yeah, that's it. Thank you for watching. Bye.